Hello everyone, my name is Sushil. Welcome to my YouTube channel. So in this tutorial we will see some standard functions about which we know what are the fundamental means time period, or we can say period of the function. Okay, so here are some functions. I'm making a table. This is very important table to find the period of any kind of function. Okay, this is function and this is period. Okay, this sin x, cos x, sec x, cosec x. The periods, we can say time period of these types of function will be 2 pi. This is standard. This is fundamental period of the function. Okay, as far as this tan x and cot x is concerned, the period will be like pi. Okay, I hope it is clear. Now sine of x the whole power 2n plus 1, cos of x to the whole 2n plus 1, sec of x to the power whole 2n plus 1, cosec x to the whole power 2n plus 1. The period of these types of function will be like 2 pi, where n is a integer. Okay, sine of x to the power 2n, sine cos of x to the power 2n, sec of x to the power 2n, comma cosec of x to the power 2n. The period of these types of function will be pi, where n belongs to integer. Now if we are taking modulus on each and every trigonometric function like mod of sin x, mod of cos x, mod of tan x, mod of sec x, mod of cot x, mod of cosec x. The period of these types of function will be pi. Here I am saying fractional function. The period of this function will be 1. Again, one more important point like this. This is constant function. This is periodic function. Periodic function, but period is not defined. I hope it is clear. These are the functions that you should note, and you should know the time of these functions, or we can say period of these functions. Okay, so one note again I want to tell you that if y is equals to fx is having a time period, or we can say period is as t, that is f of x equals to f of x plus t, then we can say a plus of x, a minus f of x, a of fx for f of x plus minus a 5, f of the period of these types of function will be again t. Okay, if the period of this function is t, then the period of this types of function will also be t. Now one more note. These are the notes that you should understand. Okay, now if a function is like f of x plus t is equals to fx, that means the period of this function is t, then f of ax plus b, the period of this function will be t divided by modulus of a. What is the meaning of that? we know the period of this function fx is t, then the period of this function f of ax plus b will be t divided by modulus of a, where a is the coefficient of x. Okay, so we will take the modulus of that portion. Okay, now what we will do, simply make again one more note, that let fx and gx, fx comma gx are two functions with a period t1 t2. Okay, then period of f of x plus minus division multiply gx will be, again we can say, LCM of t1 comma t2. I hope it is clear. This is a simple note. We will see some examples based on this. Okay, we will see the examples on the next page. Here I am taking one example like this. Y is equals to sin x plus sin 2x plus sin 3x by 4 plus sin 5x by 4. We need to find the time period of this function. Okay, fundamental period of this function. So we will simply, we know the period of this function is 2 pi. This period of this function will be 2 pi by 2. As in the previous note, I have already told you f of ax plus b, and the period will be f of that means t divided by mod of a. Similar thing I am doing here. Okay, hope it is clear. Now what do you do? You simply period of 2 pi by 3 by 4, that is 8 pi by 3. Okay, here 2 pi 5 divided by 4, that means 8 pi divided by 5. Now we need to take the LCM. So t of y will be LCM of 2 pi comma 2 pi by 2 comma 8 pi by 3 comma 8 pi by 3 comma we can say 8 pi by 5. So we need to take the LCM. So I can assume this. Okay, so LCM will be LCM of 2 pi comma 2 pi comma 8 pi comma 8 pi upon SCF of 1 comma 2 comma 3 comma 5. I hope it is clear. I want to take give a note to you. LCM of a by b comma c by d will be equals to LCM of a comma c divided by SCF of b comma d. So these are the things that you should notice. Now we need to take the LCM of this. Okay, we will simply undo the LCM like 2 comma 2 comma 8 comma 8. We'll simply do this method. Okay, 1 4 4 2 1 1 2 2 again 2 1 1 1 1. Okay, so here this is 8 pi. Okay, here SCF, what will be the SCF? We will simply do we will simply convert this as a prime number, 2 to the power 0, 2 to the power 1, 2 to the power 0, 3 to the power 1, and 2 to the power 0, 3 to the power 0, 5 to the power 1. Okay, so here what will happen? We can say 8 pi divided by we can say 2 to the power 1 multiply 3 to the power 1 multiply 5 to the power 1. I hope it is clear. I hope you know that how to calculate the SCF of a number of numbers cubed. Okay, so here will be 8y divided by 2 15 4 equals to 4 pi divided by 15. So here is the answer. Okay, so what we'll do, we will take one more example like this. We will do the more example like this. I'm going to take one example like y is equals to sine of x minus cos of x. What will be the this will be, this is the period of this function will be pi. The period of this function will be pi. So the period of this function will be pi. So answer will be pi. Okay, I hope it is clear, because we know the property like this period is pi, then plus minus will be LCM of pi comma pi. What will be the answer? This will be pi. So we can say the period will be pi. So again we can take one more example like this. Sine of 2x plus sine of y is equals to sine of 2x plus sine of 4x plus sine of 6x by 5 plus fractional part of 8x divided by 2. Okay, so here the period is 2 pi by 2, here the period is 2 pi by 4, here the period is 2 pi by 6 divided by 5, here the period is 1 divided by 8 divided by 2. Okay, because we know the time period of the fractional part of x is 1. Okay, so what we will do, we will simply take the LCM of each and every. Okay, so here t will be L of 2 pi by 2, 2 pi by 4, 2 pi by 10 pi by 6, 2 by 8. Okay, so here that will be, we can say this t will not be defined. T will not be defined because LCM of rational irrational not defined, because pi is 3.14 something. This is irrational. Okay, and the other things are rational. So this is note. This is the note. You should notice. I'm saying like this. LCM of two rationals is defined. LCM of two rationals, RSTIONALS, is defined. Okay, two irrationals is defined. LCM of two rationals is defined, and of two irrationals is defined. But LCM of one rational and one irrational is not defined. Example, L of phi comma pi is pi, where is L is the LCM. L of pi comma 3 not defined. I hope it is clear to all of you. So in the next tutorial we will see some more examples based on the periodic functions, and then we will go for the shifting properties of the graphs. Okay, till then, thank you guys.